Hello everyone, I'm Aldrich from Group 8. This video will firstly show snippets of the video we made during the interim and then present our progression of works throughout the semester. This fast forward video shows our initial experimenting with different forms and methods inspired by precedents, grasshopper scripts, fabrication methods, materiality, augmented reality, and finally photogrammetry and virtual reality. Throughout the project, we remain true to our concept of parasitism, which aimed to transform waste into meaningful structures which people could interact during their visit to the Sydney Olympic Park. We retained the rules generated from the game Sudoku and used it as a fundamental scripting tool. The next 4 slides show the several precedents that we were inspired by and had influence on our design. The first shows the simplification of modules and connection details which we adapted for our aggregation. The next presents to us an idea that the design is a self-supporting structure that could latch itself onto another module, forming a rigid tower of aggregation. The next is the connection of modules through the waffling, which is the slotting and connection of each piece into another. These images illustrate a range of pavilions crafted from recycled materials such as reclaimed wood, plastic, PVC, and metal. This informed the material palette that we experimented further into this project. After studying and learning from these precedents, we experimented with recycled materials. We also looked into simple connection details such as the slotting. Next, we looked into the material and form utilization. We plugged in the nodes into Weaverbird to create perforation that would reduce material usage during 3D printing. We placed it into Cura after to determine the ideal form, placement, and size to minimize the amount of material required for 3D printing. After the finalization of modules, nodes, pipes, we plugged it back into the L script and generated several iterations with varying densities and degrees of rotation. This video shows the process of code to production by showing the inputs of modules, nodes, pipes into the L script and then generating several iterations in Grasshopper. The next step was moving towards production of our modules and nodes. We sourced for abandoned materials, harvested them, prepared them into portions that could fit into the laser cutting and water jet bed. Plastic sourced from reverse garbage was shredded, sent to an extruder where we created new recycled 3D printing filaments for our nodes. To minimize the amount of offcuts and material, we placed the laser cut and 3D file into the Cura templates before they were sent off to print. The next few images shows the process from prototyping to developing our final model. This model was shown during the interim with much complexity, which we intended to reduce and refine. It resulted subsequent modules with lesser materials, lesser complexity, and lesser parts to assemble. We further played with the different types of material, flexibility, and the different components for each module. It is further simplified into just a few components which could provide structural lateral stability and maintain the profile of the form. We tested it in a 1:1 scale to observe its rigidity and identified issues which we may need to resolve. The next 2 pages shows our final model is a resolution of the problems encountered during interim and prototyping. We have pins to secure and strengthen each module, nodes with slots to modules to be slotted into and secured with a screw, and also slots to allow for different thicknesses and pipes to be slotted. This shows how our structure is located on site. We have envisioned the aggregate to grow onto the existing structure in the armory and continue to do so as long as people continue to bring their recycled materials. Due to the simplicity of the assembly of the structure, people of all ages can interact with it, which provides an additional activity for visitors to participate in. The next few images shows an illustration of how people can participate and interact with our design. Firstly, they would bring their recycled materials such as aluminum cans, plastic bottles to site and exchange it for a kit of parts such as the already printed modules and nodes and proceed to assemble it. However, if they have sufficient time, they can participate in the activities of the workshop to witness the fabrication of each piece. An additional layer, such as an AR game, is added to provide another activity for those who are not interested in physically assembling or moving about. This video is a summary of all things we have considered and taught throughout the semester. It includes a proposal of an educational activity that would allow visitors of the Sydney Olympic Park to participate in for 2 hours. It teaches them and shows them the conversion of materials such as plastic bottles, recycled wood and metal, and transforms them into a new structure. It teaches them also the use of Rhino and Grasshopper for digital modeling, the utilization of nodes and modules through 3D printing and laser cut, and the participation in physical assembly. With this, I would like to say thank you for your time and enjoy the rest of the movie.